Right now, somewhere in our galaxy, there's a place where space itself breaks, where time stops, where the laws of physics, everything we know, just cease to exist. And the scariest part? We have absolutely no idea what's inside. Black holes are probably the most mysterious objects in the universe. We can detect them. We can photograph them. We even named one, Sagittarius A star, sitting right at the center of our galaxy. But what actually happens if you fall in? What's at the bottom? Today, we're going as deep as physics will allow. First, let's kill a myth. Most people imagine a black hole like a giant vacuum cleaner, sucking everything in. That's wrong. A black hole is just an object with enormous gravity. If you replaced our sun with a black hole of the same mass, Earth would keep orbiting. Nothing would change. Except, it would be very dark and very cold. The dangerous part is the event horizon. Think of it as an invisible line in space. Cross it, and you can never come back. Not because something pulls you, but because every possible path forward leads deeper in. Even light can't escape, and nothing in the universe travels faster than light. So once you're past that line, that's it. Game over. Now here's where it gets weird. Let's say you're falling into a stellar black hole, the kind formed when a massive star collapses. As you get closer to the center, gravity pulls harder on your feet than your head. This difference in pull stretches you. Scientists actually call this spaghettification. Yes, that's the real term. You'd be stretched into a long, thin strand of atoms before you even reach the center. But, and this is fascinating, if you fell into a supermassive black hole, like the one in galaxy M87, which is 6.5 billion times the mass of our sun, the event horizon is so large, the tidal forces at the boundary are actually gentle. You could cross the point of no return without even feeling it. You wouldn't know you were doomed until it was far too late. So what's at the center? According to Einstein's equations, a singularity, a point of infinite density, infinite gravity, zero volume, all the mass of a dead star, compressed into something smaller than an atom. But here's the honest truth. We don't actually believe singularities are real. When our equations produce infinity as an answer, that's usually a sign that our equations are broken, that we're missing something. This is where general relativity and quantum mechanics completely fall apart. They're both incredible theories. They've both been proven right, over and over. But they're fundamentally incompatible. And inside a black hole, both apply at once. We don't have the physics to describe what's there. Nobody does. Here's one more thing that keeps physicists awake at night. When you fall into a black hole, what happens to the information that makes you? Your atoms, your memories, your entire existence. Quantum mechanics says information can never be destroyed. It can change form, but it's always preserved somewhere. Black holes seem to destroy it completely. This is called the information paradox, and it's one of the biggest unsolved problems in physics. Stephen Hawking spent decades on it. He proposed that black holes slowly evaporate, releasing what's called Hawking radiation. But whether your information survives that process is still an open question. So, what's inside a black hole? Honestly, we don't know. And that's not a failure of science. That's an invitation. Every answer we find leads to a deeper question. And right now, the universe is handing us one of the greatest mysteries it has. If you want to keep exploring, subscribe. Next week, we're asking, what happened in the very first second after the Big Bang? Trust me, it's even stranger than this.